Hey class, Mr. Houston here, back to talk to you about combinations. If you remember from our last lesson in permutations, permutations was when the order of our objects or items that we were dealing with mattered. When we're talking about combinations, the order doesn't matter. So to kind of illustrate that here with our first example, we are going to count the combination of two letters from the list A, B, C, D. So basically, you're just going to take all four of these letters, and you're just going to pick two of them, and you're going to list all possible combinations. So something like A, B, A, C, A, D. You could have B, A, B, C, B, D, C, A, C, B, C, D, and then you would have D, A, D, B, and D, D, C. Now, in permutations, these would all be possible outcomes, but in combinations, this and this are exactly the same. So one of them wouldn't count, or CA and AC, they would also be the same. So one of them would not count. So the order doesn't matter. So if A came first or B came first, it wouldn't make a difference. There'd still only be one instance of that. So with combinations, we use this formula. Again, we're still using factorials. Again, factorials are like if it is 5 factorial, we're talking about 5 times 4 times 3 times 2 times 1 times every number except 0 below that given number. So we're just going to, again, N is going to be your total number of items, R is how many you are taking at a time. So let's apply that to this first example here. So now we're doing combinations. We have 4 letters, but we're only taking 2 at a time. So we're going to fill in that formula. So again, it is n factorial, so 4 factorial, over n minus r factorial, so 4 minus 2 factorial. Now the big difference here between the last one and this one is that after we do the n minus r factorial, we also have an r factorial here at the end. So we are talking about 4 minus 2 factorial, and then that is going to be multiplied by 2 factorial. So that'll simplify to 4 factorial over 2 factorial times 2 factorial. Now, a couple of different ways to go about this. One is to use your calculator, perfectly fine with that. The other way is to list it out this way, and then do both of them down here, 2 factorial times 2 factorial, and then just learn to cancel things out that are on the top and the bottom. So I see they have a 2 here and a 1 here, so those are now canceled. I see that this 2 and this 4 have a 2 in common, so now we're looking at 2 up here. Nothing else really cancels out, so I have a 2 times 3 on top and a 1 on the bottom. So that would be 6 over 1, or just 6. So really there are only 6 combinations. Originally we looked at this problem and we had a list of 12. There are really only 6 because the order in this case doesn't matter. Okay, so that's the subtle difference between combinations and permutations. Now where would this make sense to use, you're asking yourself? And it would make sense to use, hey, if we're ordering lunch or we're ordering dinner, how many different combinations of a meal can we come up with? So if we take a look at example 2, you're ordering a sandwich at a restaurant. You can choose 2 sides from a list of 8. How many combinations of your side dishes are possible? So we will create our combination. So we will say combinations. We have a total of 8 side dishes. We are only allowed to pick 2. So it would look like this. Again, this is our n, this is our r, n factorial over n minus r factorial times r factorial. So that would be 8 factorial over 6 factorial times 2 factorial. So to kind of shortcut this a little bit, I'm going to go 8 times 7 times 6 factorial, And then down here, I'm going to say I have 6 factorial times 2 times 1. Now, why did I list out this as a factorial, the 2 and the 1, but not this? Well, because I can cancel these out without listing out 6, 5, 4, 3, 2, 1, both the top and the bottom. I can just go ahead and cancel those ones out. Okay, I can see that 2 and 8 both have a 2 in common, leaving me with a 4 up here. So up top, I have a 4 times 7, which will give me 28. And then on the bottom, I'll have a 1. So my final answer will be 28. So there are 28 different ways that I can order 2 sides from a list of 8 at a given restaurant. So we are going to use this to find probability. Okay? So we have a yearbook editor has selected 14 photos, including one of you and one of your friend to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? So the first thing we have to do is find out how many different combinations there are available when you have 14 photos and you're picking 2. So again, combinations of 14, taking 2 at a time. 14 factorial, and I'm going to shortcut this. 14 minus 2 is 12 factorial times 2 factorial. From there, I'll list out, I'm going to go 14 times 13 times 12 factorial. Again, that's because I have the 12 factorial on the bottom. So then I will do 12 factorial on the bottom times 2 times 1. My 12 factorials cancel out. My 2 and my 14 have a 2 in common, leaving me a 7. 7 times 13 is going to give me 91 over 1. So there are 91 different combinations to choose from with 2 photos if we have 14. So the question now becomes, what is the probability that we choose your photo and your friend's photo? So we'll say you and your friend, and we're trying to choose their photo. So the question becomes, does it matter the order that we choose them in? Does it say your friend has to be first and then you? No, it just says your picture and your friend's picture is chosen. So there's only one possible outcome of that, and there are 91 possible outcomes total. So the probability that you and your friend's photo is picked for the top is 1 out of 91. So pretty highly unlikely that both of your photos will be picked for the top, but there is definitely a chance. So hopefully you definitely see the difference between combinations and permutations, knowing that the order matters for one and the order doesn't matter for the other. All right, so that does it for this one. If you have any questions, bring them with you to class, and we will see you then.